So notice that I took the definite integral here, subtracted the definite integral here. So that should kind of give us a hint that maybe we can break up. So this brings us to some other properties of integrals. So if I have the definite integral from some interval a to c, I can actually break up that interval a to c and make it two intervals, and I can take the sum of each integral for a positive function. Also, if I have a positive function, that means that all the y values, all the function values are greater than 0 on some interval, then the integral is also greater than 0, which makes sense because we're just summing function values. That's what this is, the limit of sums. Also, if one function is greater than another function for all x values on an interval, the integral of one function is going to be greater than the integral of the other function. The integral sign here. And then finally, we have this property. So if a function is always greater than one constant value and always less than or equal to another constant value on some interval, then we have this expression. The definite integral is greater than or equal to this and less than or equal to this value. And we're going to look at why by looking at it graphically. So here's an example. My function f of x is x squared plus 1. So notice that x squared plus 1 is always greater than 1, and it's always less than 5 on the interval 0 to 2. Lowercase m is 1, uppercase m is 5, and a and b are 0 and 2. So the area under m equals 1 is this blue rectangle, and that just has area 2 times 1, which is 2. The area under capital M equals 5 is this green rectangle, and that has area 5 times 2, which is 10. And then, now the area under this curve is obviously going to be greater than the area under this rectangle where bounded by M equals 1, and it's going to be less than the area bounded by this larger rectangle with made by M equals 5. So that's why we can say that the definite integral is less than this value and greater than this value. These are just areas of rectangles. In summary, the definite integral from a to b of f of x dx is just a number, and it's defined as the limit of those Riemann sums, where we can use actually any endpoint we want, midpoint or endpoint. It doesn't matter. So just remember that if you're asked for an estimate, you find the Riemann sums. If you're asked for an exact value for a definite integral, you actually need to take the limit of these sums. If the function is not positive on an interval, this definite integral is the net area on a to b. But if it is positive, then it is the area under the graph.